I have a king piece in this 4x4 chessboard. Now the king could move one step at a time. It could either move to the right, go down, or go to down and right one step at a time. Now the question is, how many ways can it move from the top cell to the bottom right cell here? Okay, so this is a class of problem that use recurrence. Okay, so the idea is that in order to reach let's say a cell in the middle here, highlighted, you can only come from 3 possible previous steps, either from top, from left, or from this cell, adjacent cell, 3 different directions. Okay, so which means if the number of ways to reach this particular position is x, at position, let's say it's ith row, jth column, the relation here is that this number here, the number of ways, is going to be the summation of the number of ways to reach the top cell, the left cell, and top left. Okay, so in other words, the recurrence relation is governed by this, where ith row, jth column. And then how do we solve the problem? We're going to use this recurrence. We're going to build from the bottom up. Okay, so iteratively we calculate. Notice that for the top cells, there's one way to reach, right? You can only go from left to right. Okay, similarly for this one, there's only one way to reach. You go down, no other ways, yeah, because you're at the bordering cells. Okay, so that's all ones. Now for this one, however, it's going to be 3 different ways, because 3 different neighbors, you add it up, that's going to be 1, 1, 1, that's 3. Yeah, so once we have this 3 here, you can calculate this one here is going to be 3 neighboring one, which is 5, right? And similarly, this is actually symmetric, so that means if this is 5, this must also be 5, because this is a symmetric structure here, right? 5. Once you have 5, you can know this cell here is going to be 13. Yeah. Once you have 13 here, for this cell and this cell is symmetric, it's both equal to 7 here. 5, 1, 1, 7, and 7. And once you have that, this 2 cells is symmetric again. It's going to be the 3 neighboring one would be 25. So we have 25. Now the final cell here is going to be the summation of the 3 neighboring, which is 50 plus 13, that's 63. That's the recurrence to solve this problem. If you learn computer science, there is a classic recurrence problem, that is climb the stairs. So in this statement, you can climb up either 1 step or 2 steps at a time. The question is how many ways you can go from the bottom stair to the top if there's n stairs. Now the recurrence, however, is that in order to reach at the nth step, you're going to either come from the previous one or the previous minus 1, right? So n minus 2 and n minus 1. So xn is equal xn minus 1 plus xn minus 2. That happens to be the Fibonacci sequence. All right. This is a classic example. If you take computer science class, you're going to learn how to program that, either using recursion or iterative method, right? So anyway, please like, share, and subscribe to the channel.